Hello students, today we are going to take up the topic ozone. Ozone, the meaning you know already, the formula you know already, O3. So let us start the session with a very good thought. Keep calm and accept the challenge. When you accept the challenge, you can convert your problems into opportunities. Let us start. So the learning outcomes from this session is you would be able to explain about manufacturing of ozone by Siemens ozonizer, thermal decomposition of ozone at high temperature, oxidizing nature of ozone, that is very important, and the reactions of ozone with lead sulphide, potassium iodide and mercury, and further to that uses of ozone. Let us start. So see here, this is ozone. So you can see from the surface of Earth there are layers. Troposphere, ozone layer is coming under stratosphere, which lies in the 10 to 50 kilometer from Earth's surface. So what these rays are doing? These rays are preventing the penetration of harmful ultraviolet radiation that you are studying from the very middle classes onwards. So problem is there, the ozone hole is there. So ozone hole is there due to the destroying of ozone layer, and what leads to destroying is chlorofluorocarbons and the oxides of nitrogen. And this ozone that is present with the natural reactions in the atmosphere, and that is present in 10 ppm. Okay, so this is the structure of ozone. If you do remember how to calculate the number of bonds, so you know that 6 valence electrons are there in oxygen and there are 3 atoms of oxygen in ozone molecule. So 6 into 3, 18. And if 3 maximum to maximum for octet completion 8 electrons are required, 8 into 3, 24. 24 minus 16, it comes out to what? 18 and 6. 24 minus 18 is 6. 6 divided by 2 is equal to 3. So 3 bonds would be there. So one side you can make 2 bonds and another side make 1 bond. But you know that single bond is having larger bond length than double bond, but with X-ray analysis it was found that the bonds, 2 bonds are equal. So therefore the concept of resonance comes into play, and the length, bond length is 1.278 for both the bonds of oxygen in ozone. Okay, so this way we have drawn the structure. So when you are drawing the structure, so please make sure that you are focusing on the number of electrons should be same. Okay. So like here 2, 4, 6, 7 is mentioned, so negative charge is here. 2, 3, 4, 5, 1 is less, therefore positive charge is there. So this thing you have to keep in mind. Fine. Now in regard to properties of ozone, pure ozone is pale blue gas with a characteristic pungent smell. It is slightly soluble in water. Then there it is soluble in CCl, or carbon tetrachloride, soluble in glacial acetic acid, soluble in turpentine oil. And ozone is thermodynamically unstable. So it means at high temperature it may decompose to oxygen, and these reactions are exothermic, but at default starting the temperature is required. Okay, so if you want to do it in the lab, then you need 573 Kelvin of temperature to decompose O3 to O2. Then afterward the reaction will proceed because it is exothermic reaction. So now the preparation of ozone we are talking of now by Siemens ozonizer is in their syllabus, but in the book you will find different methods. In the book you will find some Brody's ozonizer, you will find Siemens Halseke ozonizer, but that is not there in the syllabus. Syllabus Siemens ozonizer is there, so I will stick to that. So here what we are doing is we are converting oxygen to ozone. Okay, so here I have done little error. The reaction we have written is it should be opposite. Okay, so it should be O2 to O3. So here we are passing O2 gas, and this is silent electric discharge is there. Why silent we are doing is silent electric discharge we are pointing here, because that if temperature is more, then again O3 can go back to O2. That's why the silent electric discharge means sparkless, no spark is there. Okay. And the ozonized gas which we are getting, that is only having 10 to 15%. The rest is again oxygen. So only 10 to 15% is converted to O2 to O3. So please make sure that you are changing the equation. I have written wrongly here. Here will come as 3O2 give rise to 2O3. Okay. Fine. So this is endothermic reaction, and tin foil coating is there on the outer surface and the inner tube inner surface also. Now here, how the ozone is produced naturally in the air, naturally in the stratosphere. So here O2 molecules are present, then on the presence of ultraviolet radiation, this may decompose into atoms. These atoms will again combine with O2 to form O3. So this is the way how the formation of ozone takes place. Now here sunlight is used there in the lab, Siemens ozonizer. We are using silent electric discharge. This is only the difference, and tin foil coating is there. Now what is the difference between ozone and oxygen? Now you know that ozone is an allotropic form of oxygen, and ozone is existing in the form of O3, and oxygen is existing in the form of gas, that is dioxygen gas. And ozone was first detected by von Marum in 1785 by passing the electric discharge through oxygen, the same manner we have done now in Siemens ozonizer. And for the allotrope of oxygen, that ozone is allotrope of oxygen, it was found by Soret in 1866. The point now here I want to discuss is the molecular weight of ozone is 48 and oxygen, both gases are heavier than air. And the color, oxygen you know colorless, but ozone is light blue. And that color may change into violet also depending upon the temperature condition when it turns into solid. Smell after lighting storms, and that is waterless. Solubilities, as we have discussed already, it's oxygen is having 0.049 and the ozone is having 0.64, still less. Density is 2.144 and 1.42 for oxygen. Oxidizing potential is 2.07, 1.23. Ozone is the most powerful oxidants used in water and air application. Water, you want to see that water, we are seeing that ozonization you are doing, ozonized water for killing the bacteria. Similarly here, in let us say in the shopping malls or in the let us say in the movie theaters, this ozone is used for as a disinfectant. Now here decomposition, as I told you earlier also, decomposition takes place at 573 Kelvin, and apart from that you can use catalyst also like platinum, copper oxide. So this also helps in decomposition of O3 to O2. Similarly, this is the most important topic of this chapter, that is oxidizing property. Very important. Always question is coming from this property, oxidizing. O3 gives rise to O2 plus O. How question will be asked next, we will see on the next slides. Reducing property, H2O2 is reduced to water. So this property is reducing property. So this was earlier very important. Nowadays they are not putting that much question, as not specified in the syllabus also. So this is about thermal decomposition. As I already told you, apart from this temperature of 573 Kelvin, we can use the catalyst also, which helps in the decomposition of O3 to O2 in a very good manner. Now these reactions I told you, that is very important. Oxidizing action. So what it means? Ki in the presence of neutral medium, Ki plus O3 plus water gives rise to KOH, O2 and I2. So here you check the oxidation number. -1 is the oxidation number of iodine in Ki, and here it is 0. -1 is changed to 0. It means what happened? Oxidation. Who has done oxidation? Ozone. Therefore ozone is acting as an oxidizing agent. Similarly, O3 gives rise to O2. PBS is a black painting made of lead, because lead is there. Lead, when oxidized with the presence of sulfur impurities in the air, it may convert it into black, PBS. So to convert back into white, we are doing ozonization. PbSO4 is formed, that is white in color. So this third question also is very important, that is mercury is changed into mercurous oxide, and this, when as such a mercury is there, it will not stick to the glass, but when we are doing ozonization, it will stick to the glass and it will leave the trail on the sides of the test tube. So that is known as tailing of mercury. This reaction is very important in the name of tailing of mercury. Very important. These three of the reactions are very important. Now reactions, some more are there, as such they are not specified in the syllabus, but we can just see the similarity is there. Ki plus water plus ozone, which we have done already just now, KOH plus I2 plus oxygen. And this iodine, when it comes in contact with starch iodide paper, it will turn into blue. Now the point is, this reaction, although it's not mentioned in the syllabus, but we are doing Ki plus ozone in the presence of alkaline medium. The medium is alkaline. Previously the medium was neutral. So here what will be forming is KiO3 plus O2. So potassium iodide and O2. Ki plus 4O3 gives rise to potassium periodate and O2. So these two reactions are there, although not mentioned in the syllabus, but mercury reaction is very important. Mercury usually is discussed on contact with water. This is the process known as tailing of mercury. Mercurous oxide is formed along with water, oxygen. So now how the chlorofluorocarbons deplete the ozone layer in the stratosphere. So let us say chlorofluorocarbons are there with us, and in the presence of sunlight, in the presence of radiations, it is converting into radicals, Cl dot radical. That's a chlorine radical. Radical is a neutral species. So chlorine radical react with O3 to give rise to ClO dot plus O2. So again radical is produced of chlorine monoxide. So then if this radical will react again with O3 to form O2 as well as chlorine free radical. So it means now chlorine is again regenerated, it will again start the reaction. So thereby depletion of ozone layer takes place. And what are the pollutants? That is basically, as we discussed the reactions is chlorofluorocarbons along with that nitric oxide, that is the exhaust which we are sending as a flare gases to the atmosphere with the industries, with the automobile vehicles. These are called nitric oxide, NOx. NOx also we say. Similarly, oxygen atom and OH radical also is used. They are the pollutants of the environment and which is depleting the ozone layer. Now here how the depletion takes place, you can see if O2 molecule is there, and not O2, if C we are having, let us say this chlorine atom is there and ozone is there, let us say ozone, what it is doing is the chlorine radical which was produced earlier, it will decompose. Chlorine will decompose O3 to give rise to ClO and O2. ClO again will react with oxygen to form chlorine plus oxygen. So the overall reaction will be O3 when combined with O. O we can get from any radicals. So that will be giving you O2. So this is how the depletion of ozone layer takes place. So this is the condition of ozone hole. If you see the 2014, 15, 16, 17, 18, 19, there is shown the recovery in 2019, 18. Okay, so it is a good sign for us. So we should try to reduce the use of chlorofluorocarbons as well as the emissions that caused, like the jet plane emissions or the automobile emissions, which is creating the nitric based oxides like NOx. So this is how that regeneration takes place. Automatically the O2 present in the air will react with ultraviolet radiation to again give us the oxygen atom, and then oxygen atom will combine with O2 to form O3. This is a natural process happening in the stratosphere. So let us come to the main point, that are uses of ozone. That is very important. Uses of ozone includes that it is used for the purification of crowded places like cinema halls, that I already discussed, and tunnel railways. It is strong oxidizing power and it destroys the foul smell in slaughterhouses also. It is used in fossilizing water by oxidizing all germs and bacteria for preservation of meat in cold storage. So these are the most important uses which we are finding herein. Apart from that, bleaching action, I told you just now, PBS is converted to PbSO4. So this also is there. and it's also used for manufacturing of artificial silk and synthetic camphor, and it is also used in the conversion of potassium permanganate from potassium manganate. Means to say that K2MnO4 to convert to KMnO4. That can be done by use of ozone. So mostly we are done. If you see the organic chemistry also, ozone is used in the ozonization of alkene and alkyne. That we will discuss in class 1. We will do it again in the organic chemistry there. And other thing is bleaching also we discussed. If any question is coming like the reaction of ozone with KNO2, so you need not do much. So KNO2, you know, potassium nitrite will be converted to potassium nitrate like KNO3. KNO2 will be converted to KNO3. KNO2 plus O3 gives rise to KNO3 plus oxygen. This way we have to solve. So the summary for all this topic is pure ozone is a blue-black gas, pale blue gas, and it can turn into dark blue and liquid state and violet black in solid state. Ozone is thermodynamically unstable with respect to oxygen, and at a temperature of more than 573 Kelvin or greater than 300 degrees Celsius, it can be decomposed to O2, and two oxygen bond lengths are of same length, that is 128 picometer, due to resonance in the molecules. And it is used as a germicidal, disinfecting, and for sterilizing water. It is also used for bleaching oils, ivory, flour, starch extra, act as an oxidizing agent. And the manufacturing of potassium permanganate also from K2MnO4. So let us try to understand that how much we have learned. It is by the use of ozone lead painting, which turns black due to atmospheric pollution, turns white. T is missing here. So like the reaction when potassium iodide solution reacts, neutral reacts with ozone. So this reaction we have already discussed. PbS plus O3 give rise to PbSO4 plus 4O2, and Ki plus water plus ozone give rise to KOH plus I2 plus O2. So this is ionic equation, this one, and this is molecular equation. I think molecular equation you can write, that is easy to understand. Okay. Next question is regarding to jet planes are responsible for ozone layer depletion. How? Because we know that jet plane emissions generating nitric oxides, nitrogen oxides, and this rapidly decompose the ozone layer to convert it to O2. So this reaction is written here, and this happens in the stratosphere region where jet airplanes are flying mostly. So hopefully you are knowing all these answers, and congratulations to you. Thank you for patient hearing. Thought for the session is keep calm and accept the challenge. Keep smiling. Thank you.